Good morning, everyone. In today's session, we will learn probability. In class 11, you have learned how to find the probability of an event. In class 12, we will start from conditional probability. So, what is conditional probability? Here we have to find probability of any event under certain conditions. So let us define the conditional probability. Let there are two events A and B associated with a random experiment. Then the probability of occurrence of event A under the condition that B has already occurred and probability of B is not equal to 0 is called conditional probability and is denoted by probability A/B. So you can read as probability A/B is nothing but probability of A when B has already occurred. Now this you can understand with the help of one example. Suppose one bag has 4 red balls and 6 black balls. Now 2 balls are drawn successively without replacement, and it is known that first drawn ball is red. What is the probability that second drawn ball will be red? So here we define event A is first drawn ball is red. Now event B, second drawn ball is red. Second drawn ball is red. Now we have to find second ball drawn should be red. So that means probability of B, and it is given that A has already occurred. That means first drawn ball is red. We know this. So just you try to find the probability. During first drawing, you will get 4 red balls, and first drawn ball is red, you know. So during second drawing, number of red ball will be 3. So favorable number of outcomes is 3, and total number of balls, that is 3 plus 6. So 9, that is equal to 1 by 3. So this type of questions are called based on conditional probability. So we will see more questions in exercise. So conditional probability is defined as number of elements in A intersection B divided by number of elements in B. If we divide numerator and denominator by NS, then probability of A intersection B divided by probability of B. Similarly, we can define probability B A is equal to probability A intersection B divided by probability of A. Now some properties of conditional probability. First property is probability of SA is equal to 1, and probability of AA will be also 1. How do we prove this? Probability of SA is equal to, according to our formula, probability of S intersection A by probability of A. Obviously A is the subset of S, so intersection will be A by A, that is equal to 1. In the similar way, we can prove second part of this property also. Now, second property, let there are two events A and B. A and B are two events associated with sample space S, and C be another event such that probability of C is not equal to 0. Then probability of A union B C is equal to probability of A C. Third property is probability of A dash complement is equal to 1 minus probability of A B. And this formula you have learned in class 11. Once again I am writing this. Probability of A union B is equal to probability of A this formula is also very useful here. Now questions from exercise first exercise is 13.1. Exercise 13.1 and question number 5. 5 is PA is 6 by 11. Probability of P is 5 by 11 and probability of A union B is 7 by 11. Then find first part is probability of A intersection B. Second part is probability of A B. Third is B A. So for first part, probability of A union B. We have formula for union. So PA PB minus B A intersection B. A union B is here 7 by 11, 7 by 11, PA 6 by 11 and PB 5 by 11 minus A intersection B. We have to find that A intersection B. So probability of A intersection B will be 4 by 11. First part we have completed. Now for second part. Second part is probability of probability of A intersection B divided by probability of B. Now we put the value 4 by 11 divided by probability of B 5 by 11. 5 by 11, that is 4 by 5. Now third part of this is BA. Again, probability of A intersection B by probability of A. So A intersection B is divided by A is 6 by 11. 6 by 11, so this is equal to 4 by 6 is equal to 2 by 3. Now another question number 7. 2 coins are tossed once. Two coins are tossed once, where E is the event tail appears on one coin. First part is E appears, tail appears on one coin. And F head appears, one coin shows head. Head. Second part of this question is again no tail appears and F is no head appears. No head appears. In each situation, we have to find here probability of E when F has already occurred. So in first situation, 2 coins are tossed. So sample space will be H, E, EH and EP. So first part is tail appears on one point. So E will be here. Tail appears on one point, these two, and TH. And F is one point shows head. Again the same, one point should be head. So this is HT and TH. Now intersection E intersection F is equal to same HT and TH. So probability of E oblique F according to formula, probability of E intersection F by probability of F. Here number, we can apply number of elements formula, no need to divide. So number of elements in E intersection F, E intersection F divided by number of elements in F. So number of elements 2 and here 2 is equal to 1. So if you apply this formula, probability of E intersection F by probability of F, the result will be same. Result will become same because this equal to number of elements in this, that is 2 and total number sample space. Sample space is 4. 2 by 4 is here probability of F. Again 2 by 4. So this is equal to again 1. So nothing will change. You can apply either any one of these two. So first part we have solved. Now for second part, again you find when E is no tail appears. There should be no tail. That means only this H and F is no head appears. No head appears means tail. So intersection will be 5. E intersection F will be 5. So number of elements in the intersection is 0. So probability of E oblique F is equal to number E intersection F by F. So this is number of elements is here. Intersection F. So 0 by 1, that is 0. Now another question number 11 from your NCERT textbook. A fair die is rolled. Consider the event this. Question is a fair die is rolled. Consider the event. Event is here. E 1 3 5 1 3 5 and F is 2 3 and G is here 2 3 4 5 2 3 4 and 5. The question is we have to find probability of E of the F. Find first is E of the F and F of the E and F of the E. Now second part of this question is EG and GE. EG and GE. Third part is probability of E union F of the G. Probability of E union F of the G and probability of E intersection F of the G. E intersection F of the G. For first question, E oblique F is equal to probability of, in terms of number of elements we can write. So number of elements in E intersection F divided by number of elements in F. So first of all you find intersection of E and F. So E intersection F is equal to, what is the common here? Common is only one element, it is 3. So number of common element is 3, number of elements in F is 2. So number of elements common in E and F. E and F, that is 3, yes, and number of elements in F, that is 2. But here probability should not be more than 1. So it is coming more than 1 means there is something mistake. E intersection F by number of elements in F. So now, yes, in intersection it is 1. This one and total number of elements. So this is the second part of the first question, probability of Fe is equal to number of elements in E intersection F divided by number of elements in E. Then number of common elements is 1 and number of elements in E is 3. So 1 by 3. In the similar way, we can solve second question also by taking these two events F, E and G. E and G. So second part is we have to find an intersection of E and G. So E intersection G. E intersection 1, 3, 5. So 3 and 5. 2 elements are common. So second part, that is first probability of E of G is equal to number of elements in E intersection G by G is equal to intersection 2 and in G 4. So 1 by 2. Now probability of G E is equal to by N E. So we have 2 and N E is 3. So 2 by 3. Now third part of this question, this one. So we have formula for this, probability of E union F oblique G is equal to probability of E G probability of F G and minus probability of E intersection F. E intersection F oblique G. So here E oblique G, we got the value of E oblique G and this value we have to find. Probability of E oblique G. E oblique G which we have calculated earlier, that we will put here, and F oblique G. F oblique G also we require. So this also we have to find, and after that this probability E intersection F. So one by one how you know how to find this value and this value. Here the question is how to find this one. So first of all, you find E intersection F. So E intersection F is equal to 3. This is and oblique G. That means probability of E intersection F oblique G is equal to number of elements in E intersection F, then again intersection G divided by G. So intersection F and intersection G, again 3. So here will be 1 and number of elements in G is 4. So it is 4. So value of this is 1 by 4 minus 1 by 4. And E oblique G is, this is part E intersection G, that is 3 and 5. So 2 by 4, 1 by 2. This is 1 by 2 plus FG intersection is 2, 3. Is 2, 3. So intersection will be 2, 3. That means 2 and G 4, 1 by 2. So this is equal to 1 by 2, 1 minus 1 by 4, that is equal to 3 by 4. If you divide this, 0.75. 0.75. Okay, thank you.